So good morning or good day, everyone. So we are the first group to report all about feeders and storage silos. By the way, I am the first group's leader. I am Adrian Clark Velos from Section A. So to start our report, or by the way, the rest of my members are Christian Agua, Frederick Dablo, Kenneth Dahan, Carl Erfe, JL Hayoma, and William Lamberte. So to start off, in every plant or manufacturing plant, this thing is widely used for the transport of materials to other processing equipment. So to start off, I have to show you something in order to break the ice. So for all of you, I have a question. So between both of the pictures presented in front, so which of these do you think is the feeder that is used in manufacturing plant? So is it the first photo or the second photo? Okay, that's great. So it is the first photo in the bottom. Okay, this is the feeder that is used in manufacturing plants. So what is or what are feeders used in manufacturing plants? So does anyone have any idea about what are or what is feeders? So beside the photo that you have seen, so can we see that again? Okay, so quick visual inspection. Okay, now good. So what is feeders? Feeders in general are machines used in manufacturing plant that is used to move or transport materials or the manufactured materials or the raw materials. It can be either raw materials or the processed materials done in the plant in order to move it to a designated storage or to another processing equipment. So it is a kind of feeding equipment which can handle bulk materials, meaning large materials or bulky as or if I could call it just like this mouse. So this, as you can see, this is a bulky mouse, or it can also transport other materials such as grains, sands, and etc. So fun fact or fun thing or a useful thing about feeders is that it gives or it stocks it in the bin or stocks the material in the bin evenly, regularly, and continuously. So it has been widely used in cement, mining, metallurgy, and other application in the industrial and mining enterprise.
So here we are with the type of feeders. First example is the rotary feeders. What is a rotary feeders? Rotary feeders is also known as rotary airlocks or rotary valves, are ubiquitous component in a bulk specialist material handling systems in an industrial and agricultural applications. For this picture here, this is an example of a rotary feeder. This green part is where the materials are being fed to the feeders to convey system by conveying these materials into a powered pressure or vacuum. This is a valve rotation where the materials goes downward while the air goes upward by exchanging the materials with an air. Next, how does a rotary feeder works? Here we can see the material inlet. This is the material and the housing and the rotational direction of a feeder where it goes from right to left. Then this is where the material outlet goes out. Then an air leaking from the conveying system from downward to upward, and the rotor tip for housing to clearance. So where it is only a pressurized rotary feeder. Then uses of a rotary feeder. Rotary airlock. The basic use is an airlock transition to the point ceiling pressurized systems against a loss of air gas while maintaining a flow of material components. with different pressure and suitable for airlock applications ranging from gravity discharge of filters. Like for example, here we can see that the materials were put down, I were feed to the feeder, then it is exchange of an air or gas with a feeder. Then rotary valves are feeders used in pneumatic combined system dust control equipment as volume feed controls. Here an example of a rotary feeder. As you can see, it is moving. Like unlike this is just a picture. Then this is an example of a rotary valve. Next is where we can pause the video. So next is the volumetric feeder. Rotary airlock valves are also widely used as volumetric feeders for metering materials at precise flow rates for bins and hovers of silos or conveying systems. For example, this is an example of, I will start at 0. This is an example of how volumetric feeder works. The guy is turning on the feeder on and adjusting the feeding speed. Then he pours the powder into the feeder. As you can see, as he puts the powder in the feeder, there is a specific speed that volumes a specific amount of materials that were being fed to the feeder. As here you can see the main outlet where the materials put in feeders are being fed. So next is the types of rotary feeder. Angle of repose rotary feeders, or ARF, is a variable speed rotary for feeder for bulk materials that works in a harmony with the natural flow of material being fed. As unlike similar to this volumetric feeder, but the angle of repose rotary feeders is where the speed of feeder is kanang mag-base siya sa kabaga bitaw sa kanang sa material nga ginabutang sa feeder. So if mas bugdaghan ang material nga mabutang sa feeder, so mas paspas iyang tuyok. So magdepende ang material nga ginatagak siya sa feeder o ayang tuyok din sa iyang speed dayon sa rotary. So next is the blow-through rotary airlock feeder. The blow-through rotary airlock feeder is ideal for pneumatic conveying applications in food, grains, and chemical milling, baking, plastics, and pharmaceutical industries. For example, do you see this pipe? Oh, bali mo ni siya ang kanang instead nga para sa uban nga wala bitaw siya agian bitaw diretso siya tagak, like example for kaning angle of repose, diretso siya straight siya valve, wala siya kanang pag-distribute bitaw. Unlike sa kaning blow-through rotary feeder, airlock feeder, kay gagamit siya og kanang pneumatic convey applications. For example, pag tagak niya i-distribute, like example ng video. Di ba? Di ba makita nato nga after pag butang niya sa iyang mga materials nga gina-feed kinaay air nga ga-push through para next na pud niya pag-asap iya ginagusto ipadulong ang mga kuan, instead nga mag-stay put lang sa diri. As you can see, this is an example of a blow-through rotary airlock feeder. The next is the filter valve. A filter valve is low-cost solution designed for light-duty dust collector applications. Bali, kanang, for example, atong blow-through, di ba? Kay, kanina siya, kay, ang iyang purpose ng ano niya, kay, mag-kuhan siya mga dust, like for example, mga materials na kuhan, iyang i-filter ang mga dust nga, katulad yun ang bulk materials ang makuha. Nangita mo tao video pero wala ko nakita nga example, so bali mura gyud siya na nakita na mo picture. So next is the rotary airlock feeders. Drops through the rotary airlock feeders are designed for rugged applications that require an outboard bearing style where unique contamination or an abrasive product cannot be handled with an inboard bearing style. For example, kani, di ba, kaya uban feeders kay open kani siya kay ginasumpayan ni siya o kani sa taas o mga valve para ang materials ginya, for example kanani pagkaon nga sensitive bita kayo nga dili gyud dapat siya masagulan og lain. So bali purpose ani siya kay dili gyud siya ma-contaminate ang lain materials o foreign materials for kana ra gyud yung materials nga kung sa imong butang mura pud ang mogawas pud balik wala na yung lain masagol. Next is rotary airlock feeder degassing. Rotary airlock feeders are often installed to dose material in a pneumatic conveying line. As a consequence, a lot of gas conveying from line is brought to upstream by rotation and the valve and leakages between the rotor and the stator. For example, magbutang ka og material, di ba kay namo sa ilaha nga baho, di ba? Instead nga mugawas siya directly sa mubalik sa ato sa environment, sa surroundings, naa siya filter nga before siya mugawas, instead nga hugaw to nga mugawas, mahinluan bitaw siya before siya mugawas like para dili ta makadaot. For example, nagbutang kag makadaot og kuan like mga kanang waste nga radioactive nga if kuan mo or mercury if makuan mo kay masimutan mo kay madaot ka. So nagi siya pag ang hangin ana mo gawas kay ang rotation ani sa feeder, di ba, kay from right to left. So dinhi man sa left muna og amaagi ang atong bulk materials, din sa right kay mogawas tong mga pressurized nga air nga gikan sa materials nga atong gidrop. So if before siya mogawas siya directly sa atoa, moagi sa siya filter para na siya mga safetyness gyapon. So next is the knife rotary feeder. This is the feeder is used for discharge of secondary fuel, example of plastics or wood. The knife is cutting the oversized material is preventing for the rotor from blockage. For example, katong mga rotary nga magbutang kag mga kahoy, di ba kay pag di man siya basta-basta mabutang kay di man siya dali mabali, nay dako nga possibility na siya sa muungot if siya blockage, so maguba yung feeder. For example, ang knife, its purpose para katong mga blockage kay dili siya ma-block sa imong rotary, siya magputol nga ma-fix niya. Or kaning sa example kay gagmay ramay para to i-play para makita ninyo. Kita man ni kani siya, mo ni siya ang knife. Pero ang example mo gani wala ko nakita nga katong for example like wood or plastic lang, pero mo ni siya ang purpose niya. For example, kung na-wood diri o nanubra, so if maagi siya diri, maugubaan siya imong kuan. So ang purpose niya na before siya mo tagak sa main, dapat moagi siya sa knife para iyang makat niya, masakto niya ang pag kuan sa iyang materials. So that's all.
So, good day everyone. I will discuss about the vibratory feeders. So, by definition, vibratory feeder is a device that feeds material to a process or equipment using vibration. So, kang nasa picture, that is an example of vibratory feeders. Okay? Dagan man designs, dagan og types ang vibratory feeders. So, mabalaan nato na later on. So, vibratory feeders transport material using both vibration and gravity. So, tanaw nimo ng GIF, bantog siya naka-incline. It's because ang force nga gagamiton is by vibration and by gravity. So, muna siya kanang mga gagmay nga bato. So, mo fall down na siya into next process or into sa packaging na kung depende kung sa siya nga process gibot ang vibratory feeder, but wala siya ayang ginagamit vibration and gravity. So the direction is determined by gravity, so which is either down or end to side, and then the material is moved by vibration. So they're mostly utilized for transporting a huge quantity of little items. So sa makita nimo gagmay nga bato ang gibutang nga example, it's because vibratory feeder is mainly used sa small things or little things or little materials. Next is how does vibratory feeder works. So vibratory feeder is made up of two parts. Driving unit that creates the vibratory motion and the deep channel or through that holds the bulk material. So kanang nasa ilalom, kanang nailingin sa tunga nga nasa GIF, that is the driving unit. So depende kung electromechanical or electromagnetic siya or hydraulic siya. Ato na siyang i-discuss later on, but the two parts nga ga compose sa vibratory feeder is ang iyang driving unit and then ang iyang dip channel. So kanang nasa ibabaw kung asa ga ka-feed ang mga bato, asa siya ga slide, asa siya ga move, that is the channel or through. Siya ang ga-hold sa bulk material. So vibrations are caused by the driving unit, which has both horizontal and vertical force components. So if the vibration is sinusoidal and the force components are in phase, the vibration induces a straight line motion. So very common nga design sa vibratory feeder is a straight line lang yun siya or linear, but later on na special type of vibratory feeder nga atong ma-discuss. So next is we have a video para nga mas masabtan nato kung how vibratory feeder works. So diya sa video na dira by the kanang feeding area, so diya gakatagak ang mga materials nga wala pa siya na sort or wala pa siya nag-move, and then kanang gearbox diya sa ilalom muna siyang iyahang system nga gapa-vibrate, and then the two springs, and then darin siya sa iyahang feeder exit kanang gakatagak nga mga materials. So that's how vibratory feeder works. So next is there are types of vibratory feeder. So as what I mentioned ganina. So some lang ni siya, no, kay daghan kayo types of vibratory feeder. So these are the common types of vibratory feeder. The first one is the electromechanical vibratory feeder. So this type of feeders create vibration by rotating eccentric weights using electric motor. So kanan duha nga nay arrow pa nga rotating arrow. So muna siya ang electric motors, ang rotating eccentric weights nga gina-powered by electric motors nga motuyok siya, and then it will create vibration. Pero same ra gyapon siya og principle kung how a vibratory feeder works, but ilang difference is ang ilang driving unit. So ang driving unit sa electromechanical nga vibratory feeder is gagamit siya og electric motors. So they are also referred to as eccentric mass mechanical feeder. Ang next one is ang electromagnetic vibratory feeders. So electromagnetic feeders operate using the cyclic energization of one or more electromagnets. So kanang sa ubos, kanang na siya murag kuan, medyo lateral siya nga kanang box nga patakilid, so na siya ang electromagnet. So ang gi-discuss ganiya, ang mechanical gagamit siya og electric motors, ang electromagnetic is gagamit siya og electromagnets. So in comparison with electromechanical drives, electromagnetic drive units contains lesser moving parts. So kani siya kay lesser man iyang moving parts. So ang electromagnetic nga vibratory feeder usually ginagamit siya sa mas gagmay pagyud nga mga materials nga iyang gina-move. And then ang next is the hydraulic and pneumatic vibratory feeders. So this type of feeders operates using pneumatic or hydraulic oscillating piston. So ang diyang driving unit is gagamit siya og hydraulic oscillating piston, kaya nasa ubos na piston makita nato. So the main advantage of using this type is their suitability for hazardous areas. So the motors for driving the pumping units can be located in remote areas. So mainly the difference lang yun sa different types of vibratory feeders kaya ang ilang driving unit. So ang hydraulic and pneumatic vibratory feeders gagamit siya og hydraulic oscillating piston. So next type is the direct vibratory feeder. So direct or positive mechanical vibratory feeders use a crank and connecting rod that generates oscillation with a low frequency and high amplitude. So positive conveyors are rarely used due to the high vibration transmitted to the supporting structures. So kani siya kanang makita nato nga lingin, so pag muna siya ang crank, so pag tuyok di ana siya ang mo generate og oscillation. So by oscillation mo create din siya og vibration kana mo spring diri sa tunga. So same principle, pero yung gigamit is gagamit siya og crank nga naay connecting rod. So muna siya ang principle sa direct vibratory feeders, but kani siya nga vibratory feeder is rarely used siya kay tungod kay kusog kay siya mo vibrate sa other parts. So dili siya pwede sa mga gagmay nga materials kay uyog kay siya, so possible manglagpot sila or mang exit sila sa iyahang channel kanang straight line. So kani siya is dili kay siya ginagamit kay aside sa tungod sa iyang kusog nga vibration, so possible daghan ka og maintenance sa iyang parts. Next type of vibratory feeder is the natural frequency feeder. So natural frequency feeder, also known as tuned or resonant feeders, so use 2 or more spring connected masses. So the most common is the 2-mass spring connected vibratory system. So kani siya, unlike sa past nga previous nga mga types sa vibratory feeder, so imo makita ang yang spring is instead nga na siya sa ubos, so na siya sa taas, no? So natural frequency feeder na siya, more likely ginahang na siya para nga as the vibrate gyapon ang kanang iyang spring is mag up down gyapon siya. So muna siya ang ilang kalahian. So mainly ang kalahian lang jud sa vibratory feeder is ilahang driving unit o ang ilahang design. For example, sa natural frequency feeder, ang ilahang spring is nasa taas, unlike sa uban nga type nga nasa ubos. So as what I've mentioned ganiha, so common nga type sa mga vibratory feeders kay linear siya, like sa atong mga types ganiha nga gipakita, straight lang siya, but kato sila nga mga types kasagara makita to sila nato no sa mga agricultural nga mga gamit, like sa kanang siliran sa mais kung wala mo kung kita mo ana, no? So muna siya, no, kay it will take time man kung tao lang, for example, how many hectares ang atong gi-harvest or kuan nga mais and then palapalahon. So it will take time sa pag pack or sa pag-sacking sa mga mais. So ginagamit ang kaning vibratory feeders nga linear lang siya sa para nga mas males ang labor and then mas paspas pud ang pag sacking sa mga mais or sa even palay or rice, mga bugas. And kaning sunod, vibratory ball feeders, so kasagara makita ni siya sa factories sa kanang mga tambal or sa any factories kasagara kani gid ilang ginagamit. So ang vibratory ball feeder isa siya a special type of vibratory feeders that have through wound helically. So unlike ganiha, ang channel ganiha linear lang siya is helical, so gatuyok siya. So these machines use vibration to toss and shuffle the materials along the slightly slanted surface of the helical through. So because of the tossing and shuffling action, parts with a symmetrical shape tend to be oriented as it moves through the ball feeder. So muna siyang ginagamit sa mga factories para nga isort or ma-orient og tarong. For example, pagbutang nimo sa materials diri sa tunga, daghan kay na siya nagkatumba-tumba, nang tumbling, then as it vibrates, so ma-sort siya, ma-toss siya, ma-shuffle, and then mo flow siya sa iyang right direction kaning sa mga kilid nga helical o porma kang nasa kilid, no? So mutag sa tag siya na siya diya. So muna siya ang main benefit sa vibratory ball feeder. So it is not only used for conveying but also for orienting items, no? So inyo makita diya, nasa tunga gihigda, nasa kilid gihigda, and then as exit siya sa feeder, gatindog na siya. So muna siya nga kasagara gagamiton sa mga factories ang vibratory ball feeders. Kay dili lang niya i-arrange but iya pang i-orient, no? Dili lang siya mag-feed, dili lang siya maghatag og exit para sa dali nga packaging sa materials, but iya pong gina-orient ang items, no? So it is true it is not flat but has a specific profile that only accepts materials with the correct orientation. Kay kung nakahigda pagyapon ka dira, matagak na siya balik sa tunga, no? Later on atong ipakita kung unsa na siya work, no? So screening devices are sometimes attached to the ball to remove parts that are not positioned or oriented properly. So ang gayon ganiha, kung wala siya na position og tarong, so matagak siya balik sa tunga. So as magtuyok-tuyok na siya, no? So vibratory bowl feeders are used in assembly and packaging lines in industries such as electronics, automotive, and pharmaceutical, no? Kay press ani bowl silang ginagamit or mga screws sa pharmaceutical is mga tambal sa gara, no? Daghan akong gakita sa YouTube. Usually sa mga tambal na siya, tablets or kanang mga capsule nga ginasort, no, para mas dali siya ma-package. So vibratory bowl feeders ang ilang ginagamit. So nara example on how ang bowl vibratory feeder ga work. So nara, no, so muna siya ang iyang design. Na siya helical nga kuan design, unlike kaniya, but nagyapon siya linear sa iyang padong sa exit, no? So kanay makita kanang nasa tunga nga mga materials, na silang mga wala pa na sort, no? So dili kay nato mapansin but ga vibrates na siya. So para nga ma-sort siya, matindog tanan, uniform tanan, no? So muna siya ang gatong mga wala na kuan matagak balik sa tunga. So mas dali siya ipack, mas dali siya ihapon, mas dali siya compared sa katong linear, no? So in conclusion sa vibratory feeders, so recap, vibratory feeders are short conveyors used to transport bulk materials utilizing a controlled vibratory force system and gravity, no? So basta vibratory feeder yung ginagamit nga force is ang vibration and then the gravity. So sagara gyud ana is inclined ang ilahang design, no? So the general design of vibratory feeder consists of a drive unit that generates the vibratory action and a deep channel or through which contains the bulk material. So two parts lang siya, no? Ang driving unit and then ang deep channel or through nga dito ni may butang ang bulk material. And then next conclusion is vibratory feeders can be classified according to their drive unit. So method of applying vibration, the through, and the generated reaction to the supporting structures, no? So determine lang nimo ang vibratory feeders mainly good sa ilang unsay gigamit sa driving unit, kung electric motors ba siya or electromagnets or hydraulic or natural frequency lang yang ginagamit. And then last is the vibratory ball feeders. On the other hand, katong ganihan na siya helical design, are special types of vibratory feeders which have throughs wound helically with special profiles and attachments. So I hope natin nasabtan sa vibratory feeders, and that's all, and thank you for listening.
Let us now proceed to the next type of feeder, which is our screw feeders. Now, what are screw feeders? Screw feeders are industrial equipment used in transporting bulk quantities of granular solids in the forms of powder, grains, and granules, as well as semi-solids, liquids, and even non-flowing materials from one point to another. They uphold high operational efficiency by eliminating the need for the workers to manually move around loads. Screw feeders are very similar to screw conveyors in their basic structure, both of which are based on the principles of the Archimedean screw for their operation. Speaking of which, the first screw conveyor was the Archimedes screw, which was developed around 250 BC. An Archimedes screw is a form of positive displacement pump that was used to lift water from low-lying lands to the elevated irrigation ditches. The construction and driving system of Archimedes screws were improved throughout the years to increase their efficiency, durability, and speed while adapting to the original mechanism. Now, how does a screw feeder work? Screw feeders primarily consist of a rotating screw shaft that is installed within a trowel. As the screw shaft rotates, the material moves linearly. They can be designed to provide horizontal, vertical, and inclined travel paths. Several types of screw conveyors are designed to handle a specific material behavior. For example, bulk materials may be abrasive, non-free-flowing, fluidizing, or hazardous. The products handled by screw feeders are the likes of cereals, fertilizers, animal feeds, ash, gravel, cement, and other solid wastes. Several factors must be considered when designing a screw feeder, including the flow characteristics of bulk material being stored and metered, the density of a bulk material in both stored and metered condition, the maximum and minimum capacity or feed rate of process, the bulk material size, the width and length of screw feeder inlet opening, the overall length of screw feeders, and lastly, the height of bulk material in hopper, bin, or silo. For the main parts of our screw feeder, we have the inlet opening matches bin or hopper discharge, our feeder shroud that prevents material flooding, our twin mass flow, our twin screw trough, our discharge opening. We have also the solid shafting that transmits rotary motion to the gear reducer. And lastly, our independent gear boxes that drive each screw. For the types of screw feeders, we have the multiple diameter screw feeder, the live bottom screw feeder, and our inclined screw feeders. For our multiple diameter screw feeder, our multiple diameter screw feeder consists of a screw feeder with an extension conveyor. A small diameter screw feeder is located under a hop-in bin or silo and is flood loaded. The screw feeder meters the bulk material to the larger diameter extension conveyor. When the bulk material reaches to the extension conveyor, the trowel loading decreases and the bulk material is conveyed to the discharge. For our live bottom screw conveyor, our live bottom screw conveyors are used to meter and control the volume of the flowing bulk material drawn from hoppers, bins, and silos. They are usually installed at the bottom of these vessels. They consist of multiple tapered, variable pitch, or mass flow conveyor screws to accommodate the fluctuations in bulk material volume at the screw conveyor inlet. They can be used as a screw feeder to another screw conveyor. And lastly, for our inclined screw conveyors, our inclined screw conveyors offer an inclined path that eliminates the need for additional conveying equipment for transporting bulk materials to or from an elevated surface. An alternative to this type is the use of two pieces. One piece of equipment for horizontal transportation and one piece for the vertical transportation. However, this setup is expensive and consumes more space. The angle of inclination of an inclined screw conveyor ranges from 0 to 45-degree angle above the horizontal. As the angle of inclination increases, the efficiency and load capacity of the screw conveyor decreases, while the power requirement increases due to the gravitational pull and fallback of the bulk material.
So what we have here is an apron feeder. An apron feeder is a limited length version of an apron conveyor. It is also known as a pan feeder. So apron feeder is a mechanical type of feeder used in material handling activities to transfer material to other equipment or remove material such as ore or rock at a regulated rate of speed from storage stockpiles, bins, or hoppers. Moreover, apron feeders can be found in mining operations, factories, and concrete plants. It is also cannot be used in applications where precise feeding and measuring is required. So how does an apron feeder work? So first is the materials that will be carried by the apron feeder or this feed in general will be held in a large hopper above one end of the belt. The amount of material that reaches the feeder is determined by the distance between this hopper and the top of the feeder. The next is as the hopper deposits materials onto the apron, the metal pans that make up the belt travel horizontally on a conveyor belt. Then, when the tray reach the end of the belt, they dump or feed the materials into another vessel. So they discharge this feed as you can see from this diagram. So next is the types of apron feeder. So there are three types of apron feeder: the light apron feeder, the medium apron feeder, the heavy apron feeder. These these apron feeders comes in different feeding machines with different sizes. So for the light apron feeder, it is a continuous feeding machine suitable for short distance conveying of materials with the size 160. So the same as the light apron feeder, the medium feeder comes in different machines. So it is a batch feeder machine. It is the same as the light apron feeder with short distance conveying of bulk materials with particle size, but comes in different size. So it is below 400 millimeters. Both is both are used in mining, dressing plant, chemical industry, cement, building materials, and other sectors for uniform continuous feeding from storage bin to crushing, transportation, and other machinery. But for the heavy apron feeder, the heavy apron feeder is the auxiliary equipment of the transport machinery. It is used in the crushing and grading workshop of large concentrator and cement and building materials department as the silo to the primary crusher for continuous and even feeding. And it can also be used to transfer the material with large particle size, specific gravity for short distance.
Good day everyone, I am Frederick S.W. Jr. For the types of bowl feeders. First is we have this vibratory bowl feeder. It is the most common and the ones that are most readily found when searching on the internet when it comes to bowl feeders. From the word itself, vibratory bowl feeder, it use vibrations to move parts that are bulk, randomly oriented, and provide a constant feed to correctly oriented parts to the exit chute, linear track, or an assembly machine. Most common industries that use this vibratory bowl feeder includes automotive, cosmetic, pharmaceuticals, electrical, food and beverages, consumer goods, appliance, and manufacturing. Why it is most commonly used in these industries? Because it improve line efficiency. Say, for the medicines, for cosmetics, pharmaceuticals, it is indeed needed to have a line efficiency. It also decrease the downtime, operator safety, decrease decrease part wear, and also it provides a consistent and constant feed of parts. Next is the centrifugal bowl feeder. Centrifugal bowl feeders are more complex than vibratory bowl feeders. They are used in high-speed operations where vibrations are not fast enough and cannot be used. For example, here is the processing of the hot dogs, or these circular things here in the examples, because I can't find a example of hot dogs, which the bowl inside the bowl are moved in a circular direction by centrifugal force that pushes them to the edge of the conical shaped disc inside the bowl or the track. It is it is time efficient for the processing after the processing of the hot dog sausages for its packaging. The last but not the least is the conical bowl feeder, or cascade bowl feeders are a type of vibratory bowl feeder with a cone-shaped bowl. Parts are positioned on the wall inside the wall of the bowl to reduce the part circulation and abrasion. It is process the process rather is used for parts with a simple geometry. This conical bowl feeder is like the vibratory bowl feeder. It uses vibration, but here it's not as fast as the centrifugal, but it separates the parts in a orderly manner, in a clean way, neat and clean way. The process is used for parts with a simple geometry. So the parts must have the simple geometry, not like the vibratory bowl feeders that it could be used for the parts that has a complex shapes. So they have an open cavity design for the clean rooms, the pharmaceuticals industry, and the food processing. So as I said before, the conical bowl feeder has a neatly and has a consistent way of processing the parts in the pharmaceutical industry and the food processing. Silos. Silos is a storage structure from bulk goods. So from as we can see, we saw silos in movies, mostly on the farms, like the Good Dinosaur. They store their grain in their silos. So it is most commonly used for agriculture. Silos are used in agriculture to store fermented feed known as silage, and also grain, coal, cement, carbon black, wood chips, food goods, and sawdust are all regularly stored in silos. Tower silos, bunker silos, and bag silos are the three types of the silos in use today.
So we already know what silo is, and we will be proceeding to the types of silos. For the first type of silo is the tower silo. Tower silo is used for storing silage and are often unloaded from the top of the pile, first by hand with a silage fork, which has significantly more times than a regular pitchfork, and then by mechanized unloader in the modern times. Bottom silo unloaders are occasionally used, although they have issues with repairability. So tower silos are storage silo which are cylindrical structure, typically 3 to 27 meters in diameter and 10 to 90 meters in height. They can be made of many materials such as wood staves, concrete staves, cast concrete, and steel panels. Silos can be unloaded into rail cars, trucks, or conveyors. And an advantage of tower silo is that the silage tends to pack well due to its own weight, except in the top few feet. However, this may be a disadvantage for items like chopped wood. So for the next one is the concrete steel silos. So small precast concrete blocks with rigged groove along each edge locked together to form a high strength shell make up a concrete stave silo. The silo is strengthened with steel hoops around the tower and squeezing the staves into a tight ring since concrete is significantly stronger in compression than tension. So concrete steel silos are constructed using precast concrete blocks or stave that interlock. Staves used for silo construction are typically 10 inches wide, 30 inches tall, and at least 2 inches thick. Stave silos are reinforced with the exterior galvanized steel hoops, which help compress walls and provide the necessary tension for structural integrity. The next one is the low oxygen tower silo. So the low oxygen tower silos are meant to retain the contents in a low oxygen environment at all times, preserving the fermented contents and preventing mold and decay, which can develop in the top level of a stave silo or bunker. Low oxygen silos are only exposed to the atmosphere during further loading, and even the unloader chute is enclosed to prevent air intrusion. And it would be expensive to design such a large structure that is immune to atmospheric pressure changes over time. Instead, the silo structure is open to the atmosphere, but outside air is separated from internal air by large impermeable bags sealed to the silo breather openings. In the warmth of the day, when the silo is heated by the sun, the gas trapped inside the silo expands and the bags breathe out and collapse. At night, silo cools. The air inside contracts and the bag breathe in and expanded again. So the next one is the bunker silo. Bunker silo. Tractors and loaders are used to fill and pack bunker silos, which are ditches with concrete walls. A plastic tarp is placed over the field trench to keep it airtight. A tractor and loader are frequently used to unload these silos. They are cheap and they are especially well suited to massive enterprises. So bunker silos are trenches, usually with concrete walls and packed with tractors and loaders. They are filled trench that the field trenches is covered with a plastic tarp, make it airtight. So bunker silos has a few advantages, which are it holds large capacity and can be filled with conventional farm equipment. It also offers faster unloading rates and also inexpensive and is well suited to very large operation. But for its disadvantage, it has a higher initial cost and require greater care in filling and packing. And it will also not work for smaller herds. And for the next one is the bag silo. So the bag silo are large plastic tubes with a diameter of 8 to 12 feet or 2.4 to 3.6 meters and a length that varies depending on the amount of material to be kept. They are sealed on both ends and packed in a machine designed for the job. A tractor and loader or skid steer loader is used to unload them. As the bag is broken apart, it is dumped in portions. Bag silos do not require a large upfront expenditure. They can be used as a temporary solution when growing or harvesting condition necessitate greater room, but other farms use them all year. So the bag silos also has a an advantage, which it needs a lower capital investment, flexible storage system, feed is easily inventoried, can be used for small and large herds, and it also needs a fewer safety and health hazard and has lower storage losses. And for its disadvantage, it needs specialized equipment. Plastic disposal create extra labor and environmental concern. And also the bag must remain intact. Comprised bag can result in a complete loss. Next is the bins. A bin is usually much smaller than a silo and is used to store dry materials like cement or grain. Before being kept in the bin, grain is frequently dried in a grain dryer. Round bins tend to empty more easily than square bins because there are fewer corners which the stored materials can become trapped and encrusted. So what are the difference between bins and silos? So these two structure look very different. Grain bins are metal cylinders with peak metal roofs that typically have staircases or ladders on the outside. They are vented silver corrugated steel structure, fatter in diameter than silos, and have varying heights. Silo are also cylindrical but are commonly made of concrete, bricks, metals, and sometimes even wood. For the next one is the sand and salt silo. Sand and salt are stored in a conical dome-shaped silos for winter road repair. In North America, specifically Canada and United States, these are more common. The shape is inspired by natural shape generated with solids are piled up. Prefabricated wood panels with singles are put on a circular reinforced concrete base to create the dome. Front and loaders can easily fill and retrieve due to open canopy opening. These are typically found along major highways or important secondary routes. The next one is the plastic silo. Injection molding, rotational molding, and blow molding are some of the methods used to make plastic silo. A variety of polyethylene plastics are used to make them. The silo are tiny and light, making them ideal for farmers with livestock and grain businesses. Plastic silo are a wonderful alternative to traditional steel bins because of their lightweight design and cost-effective materials. Unlike fabric silos, which tend to be prone to grain rot and pests, which have left many farmers frustrated, plastic silos are more safe and secure, keeping grain fresh and unspoiled. They can be designed to be stationary hooper bottom bins or portable pallet bins. And for the last one is the fabric silo. Fabric silo are made up of a fabric bag that is suspended from a hard structural structure. Fabric based on polyester are frequently used for bag construction, with special care paid to fabric pore size. Upper portions of silo fabric are frequently made with somewhat bigger pore size in order to act as a vent filter during silo filling. Metal thread is used in some design to provide a static conductive channels from the fabric's surface to the ground. The frame of a fabric silo is typically constructed of steel. Fabric silos are an attractive option because of their relative low cost compared to conventional silos. However, when fabric silos are used to store granular or particulate combustible materials, conventional practices prescribed by established industry consensus standard addressing combustible dust hazard cannot be applied without a considerable engineering analysis of the system. So that would be all for our presentation, and thank you.